Hello my friends, today I'll show you how to create a basic RFID-based door unlocking system. With this system, a valid RFID card or tag opens the solenoid lock for 1 second. If you try to use an invalid card though, you will hear an error beep that means it wasn't recognized. To add new cards or tags to the system, I included a Learn button on the circuit board. Here is how it works. Press the Learn button and reset the device by pressing the Reset button. Keep holding the Learn button until it enters Learn mode. You will know it's ready when the corresponding LED starts blinking. Now just bring the new card or tag close to the device and it will automatically recognize and store it as valid. In this video, I'll walk you through every step of this project, from designing the schematics and PCB to manufacturing the PCB and building the device. At the end, I'll show you how to access all the project files, including PCB, schematics, and code. So stick with me and let's dive right in. First up, let's talk about the scenario behind this project. While I have outlined mine already, keep in mind that designing a scenario is a personal and subjective process. For this project, the goal is to use a solenoid lock that can recognize a single valid card, which we can change with the Learn button as described earlier. Now, you might want to modify the setup so that it can store multiple valid cards, for example, or have different learning requirements as you desired. But for the simplicity, I kept it straightforward. We need a processor for this type of projects, and microcontrollers are perfect for this job. You can use any microcontroller, AVR, STM32 or others. For this project, I choose the STM32 because it's easy to work with and add some variety to my projects. Specifically, I'm using the STM32F030K6T6. It's affordable, has all the GPIO pins I need, and yes, I already had some on hand. So let's add the STM32 to our schematics. In the next step, we need to add the RFID module to the schematics. It's simple, affordable module that you can find pretty much everywhere. Now you might be wondering how I knew which pins to connect to the microcontroller. To be honest, before starting, I researched this module, looked at its pinout and studied the data to understand the connections. Yes. Anyway, let's move on to the next step. In the next step, we need to add an AT24C33 EEPROM chip to the schematic. You might be wondering, why is it necessary to add memory to this project? It's a great question. Actually, we need a place to store card data so it won't be erased when the power goes off. Sure, microcontroller has internal memory like RAM or flash, but RAM resets when powered off and flash isn't changeable. That's why we need EEPROM memory, because it's permanent and rewritable. Now for the main feature, the solenoid. I'm using a small 12-volt solenoid to control the lock mechanism. Solenoids can draw a lot of current. For example, this solenoid, which is a relatively small solenoid, can draw up to 500 of milliampere or 1 ampere. So we can't connect them directly to the microcontroller, which can only handle small voltages and currents. Instead, we'll use a power transistor, the TIP122, to act as a switch. We'll connect the positive end of the solenoid to 12 volts and negative end through the transistor to ground. A resistor connects the transistor's base terminal to the microcontroller and we are good to go. To protect the circuit, I've also added a freewheeling diode across the solenoid. For the buzzer, I'll use a similar circuit as it needs more current than the microcontroller can provide. This one is a 5-volt buzzer, so I'll use another transistor circuit for it. In the next step, I'll talk about the power system. For this project, I'm using a 12-volt supply since that's what the solenoid needs. The power enters through a 2-pin terminal with a fuse and protection diode. I then convert the 12-volt to 5-volt with an L7805 regulator for the buzzer, and then down to 3.3 volts with an AMS1117 regulator to power the microcontroller and the EEPROM IC. Finally, the housing. I picked out this plastic box, measured the internal dimensions and designed the PCB to fit. I transferred the schematics to the PCB designing environment, routed the connections, and exported the files. Then I printed the negative film for laminating onto a plain copper clad board, and after a ferric chloride bath to etching excess copper, drilled the holes for component mounting. After soldering the components, I tested the circuit with the power connected. If everything is in order, the last step is programming the microcontroller using STM32 IDE, which I use to write and upload codes. By the way, all the files needed to build this project, including PCB, schematics, and codes, are available in a link in the description of this video. Anyway, thanks for watching. Don't forget to like this video and subscribe to my channel, and check the description for the project files. See you in the next video. Have a good one.